So there's a lot of little things involved with writing a chemical equation. I just kind of thought that I would use an example. This is on page 113 in your textbook. I'll make a little note there. It's all review from Science 10, so that might reassure some of you, and it might freak some of you out because you're like, what? I don't remember this. But we're just going to go through it step by step, and I'm going to use liquid mercury reacting with oxygen to produce mercury oxide to be sort of my example, because I want to show you all the little bits and pieces that go through it. So if I'm going to make a chemical equation to represent what's happening here, then I need to go through a series of steps and make sure that I'm balancing everything and that everything's represented properly. So I guess I should note that this guy's a solid before we begin, because that's going to matter later on. We have to include the states. So it says liquid mercury, so I'd look up on the periodic table what the symbol for mercury is, or you could use the alphabetized one in the back of your book, and it will tell me that the symbol for mercury is Hg. Reacts with oxygen, so I go plus O, to produce mercury oxide. But before I go further, there's something about oxygen that you need to remember. Oxygen is one of the diatomic 7. No, you will not be told that it is one of the diatomic molecules when you're going through this stuff. You're expected to know what the diatomic 7 are. The diatomic 7 will always have 2 atoms stuck together in the molecule. So on the periodic table, there's a little group like that. Oops, not like that. Well, I guess like that. That looks like a 7. And then there's another one that's kind of by himself. And these are the diatomic 7. Hopefully you remember them, but if you don't, you might want to make a note because it's important. You won't be told that they do this. It'll just say that. So remember the diatomic 7. They will always be in 2s. And that's going to matter, not just in this form, but when we balance the equation. So hydrogen is the one that's kind of by himself. Hydrogen's a very unique element, so it's kind of off by itself most of the time. And here we have the halogens. So fluorine, chlorine, bromine, iodine, that's the other one. And across the top, we have oxygen and nitrogen. So those are the diatomic 7, and it's helpful to remember when you're looking on the periodic table that these guys make a 7, but there's only 6 of them, so you need to remember that hydrogen, being the exception to every other rule, is actually combined with these guys. There's your diatomic 7. Don't forget them. Anytime they come up in an equation, they're going to be 2. F2, H2, N2, O2, Cl2, Br2, and I2. Get the trend? All right, back to this thing again. Mercury oxide. So it's going to be mercury and oxygen, obviously, but we don't know what the ratio is unless we look at the charge. And we know that oxygen has a -2 charge, and if we look up mercury, we'll find that it also has a -2 charge. So HgO is going to be a 1-to-1 ratio, and if this one is a multivalent, usually if they don't specify, yeah, yours doesn't even show the charges, so you'd have to, they would probably tell you that in the question if it's a multivalent which charge it is. So we're just going to go with this for now. So I've got my charges. Whoops, that's a plus, my bad. Metals are always positives. So I've got +2, -2, those cancel out. It's a 1-to-1 ratio, so it is HGO. It's not Hg2O or HgO2 or anything like that. And now I want to look at, it tells me what phase they're in. So mercury is a liquid, so I'm going to use a little L here in brackets. Oxygen's a gas because it's oxygen. They won't always specify if they expect you to know. And HGO, they told us is a solid, so I'm going to put a little S in brackets there. That's what those mean. The other one that you'll see is AQ in brackets, and that means it's aqueous, dissolved in water. So we've got our elements written down. We know what they've created. We know that they're liquid, gas, and solid. We've got our charges balanced. All that's good. We would look now at, is the equation itself balanced? So I've got a mercury and a mercury, O2 and O. That's not balanced. So I would add a 2 here to make these two balance. And since this one's by itself, it's pretty easy. I can just put a 2 here, and now that one's balanced. So I've gone through and balanced the equation at the final step. Yes, you have to balance the equation. Otherwise, you're violating the laws of conservation of mass, law of conservation of atoms, law of a whole bunch of laws. So we don't want to violate any laws.